Hello everyone, welcome back. In today's presentation, I am going to discuss about singly linked list. Today we are going to cover the following topics. The first one is types of linked list, and next is singly linked list, operations on singly linked list, structure definition of singly linked list. In previous presentation, we have discussed about what is linked list, what are all the advantages of linked list over array data structure, and linked list representation. So we'll start types of linked list now. So we have generally this linked list is categorized into three types. One is singly linked list, doubly linked list, and next is circularly linked list. We'll start with what is singly linked list now. As the name suggests, singly, it has only one data field and only one address field. So a singly linked list is a linked list in which each node contains only one linked field pointing to the next node in the list. So obviously your node contains one data field and one address field. Let's see the representation now. So this is the representation of singly linked list. So here the node, this is called the node. So it contains one data field, which means this 5 represents the data. So this is your data field. And next this 1000 is nothing but the address of your next node. Okay. This tens address is 1000. This tens residing at 1000th memory location. So that address is represented in next field. Okay. So your singly linked list contains two fields. One is for storing the data and another one is for storing the address of the next node. So likewise, if you notice here in the next field you have 1000. Next field you have 1000. It represents the memory address of the next node. So here our first data is 5 and my second data is what? 10. Second data is 10. So 10 is in which memory address? Which location? 1000. Okay, so 1000 is my memory location. So this is stored in the next field. You all know next field contains what? The address of the next data element. So here next data element, which means after 5, 10 is stored. Okay. So this 10 is residing at which position? 1000. So this memory address is stored in first node address field. Okay. Same wise, just consider your third data 15. It is residing at 2000 memory location. So the 2000 is nothing but the memory address of 15. Okay. So this 2000 is stored where? In the next field of the previous node. That is after 10, this field represents what? This is data field. This is data field and this is address of the next node. So this field contains the address of the next node. Am I right? So this 2000 represents the address of the next node. So the address of next node is what? 2000, which means 15. After 10, 15 is stored. So 15 is the next data element of 10. Am I right? So 15 is at which position? 2000. So what I am doing? I am going to store this 2000 in the previous node address field. So likewise only address gets stored. So this is your singly linked list representation. And this since this 15 is my last data, I am representing this node, this next field with null. So this is nothing but what? Null pointer. Okay, this is represented for, this indicates that it is the last data element, or this is the last node in my linked list. So this is the null pointer. So likewise only your singly linked list representation will be. You have only one data field and one address field. So that address field represents the address of the next data element. Okay. Next we'll see singly linked list with header node. So you have some advantages if you use header node with linked list. So the header node is at the very beginning of the linked list, which means it will be the first node in your linked list. So with this, with the help of this header node, so in this header node, we can hold the address of the first data element in the list. Okay, it will not hold any actual data. It will hold the address of the first data element. Okay, we'll see the representation of the header node. So this is the representation. So this is your header node. So it is at the beginning of the list, which means it is the first node. Your header node will be the first node in your list. It will not hold any actual data item. Okay, it will hold the address of the first element in the list. So just consider my list 5, 10, 15. Okay, so 5 is my first data element. Okay, so first data element is 5. It is at the location, which means it is at the position, address, memory address is 1000. 5's memory address is 1000. So I am going to store this 1000, the first address or first data's address in my header node. Okay, so my header node will be at the starting of my linked list and it will hold the address of my first data element. And this 1000 is not the actual data and this is the address of my first data element 5. Okay, so this is the advantage of header node. With the help of the header node, we can easily track the list. Next is operations on singly linked list. So we have we can perform following operations like inserting a new node in the beginning of the list or in between or at end. The same way deletion is possible, displaying all the data items, and searching, which means finding a particular data in the linked list. So these things can be possible. These are all the basic operations on singly linked list. And next is declaration of singly linked list in C language. If you want to create singly linked list, obviously your singly linked list consists of what? Collection of nodes. So for each and every node, you must allocate memory. Am I right? So before allocating memory to the nodes, you must declare the node of your singly linked list. So we'll see how to do that. First, just consider this representation, singly linked list node representation. We all know it has two fields. One is data field and another one is next field. Okay. For instance, I'm going to have integer data. I'm going to hold integer data, and obviously my next field indicates what? It contains the address of your next node. So this next field contains the address, okay, which means the pointer. So this data type is of what type? Pointer data type. And your data is of integer data type, and here next field is of pointer data type. We'll see the declaration part now. Here I'm going to use structure. Okay, why I'm using structure? Because my first field, data field, is of integer data type and my second field is of pointer data type. These two are different data types. To club different data types, I'm going to use a concept called structure. Okay, so I'm creating a structure for my node. Here struct is the keyword for structure and node is nothing but the name I have given for my structure. Okay, I'm going to create a structure for node, right? So I'm just naming it as node. My structure name is node here. So inside this node, I'm having what? Data field and next field. Am I right? So that I'm just indicating data, int data. I told you I'm going to hold integer data type. So I have used int data. So inside my node, I'm going to have two fields. The first is data field. It is of integer type. So I have declared int data. And the next thing is, what is the next field I'm having? Address field. That is next field, which means it holds the address of the next node, right? So for that, I'm using self-referential structure. This we call it as self-referential structure. Just check the declaration here. Struct node star next. Here struct node is nothing but the self structure, right? The same structure. So this means what? My next field contains what? The address of the next node. So my next node is also going to have what? Two fields, like the same data as well as the next field, integer data type and the pointer data type. Okay, so that I am using self-referential structure. Okay, so this is the concept of self-referential structure, so that we have used here, because my next field is going to hold the address only, but that address points what? A node. So node again contains what? The same data as well as the next field. My next node is also. Okay, for that purpose I am including struct node. So this struct node acts as a data type for my next pointer. Okay, for next, my struct node acts as a data type like integer. So here integer is a data type for data, right? Likewise struct node is a data type for this next. Okay, I'm indicating that next is going to have the two things. Next node is going to have two things, the same way data and the next field. Okay, so the struct node represents the self-referential structure of the same type. Okay. The next is recap of the session, and we have discussed about types of linked list and what is singly linked list and its representation, some operations of singly linked list, and then structure definition of singly linked list.